Engineering. He has something else that he has on his. I can't remember. I looked it up.
Make sure you shine that.
I looked it up one time. I don't know what he has. I looked it up. I don't remember now. It's been a long time.
You gotta shine the head.
All right, so here we go. Everything we do today is on the exit ticket. Now, there's some stuff that I won't get to that's on the exit ticket also, but if I go over it today, it's on the exit ticket. There may just be one question on it, or there may be multiple questions on it. What are you doing? All right, so this is the first thing. So in general, it's everything that we've done on exponent. Like even the very, very first stuff we did when you had all the exponent rules. Now, the older it is, the less of it that's going to be on there. Like, so geometric sequences, there's a lot of that going to be on there. Growth and decay, there's quite a bit of that on there. The other stuff, there's a little bit here and there. How do you tell if a function is exponential or linear? You're supposed to be doing this without.
It goes straight across multiplication and then straight line. Oh, it's like on the line.
Well, no, notice I didn't give you a whole lot of details in that, did I?
That's because the wording. Exponential always means something that's always rising up constantly, bigger and bigger.
What about the y values? Well, the wording, if it said exponential, then you'd already know.
Like the pattern of the y value.
What about the pattern of the y value? Somebody else. So if the pattern of the y, now, what if we don't have any numbers? What if there's not a table there?
So again, you use the wording.
What wording are you talking about?
The exponential or linear.
Well, if it's exponential, then that tells you.
No.
I'm saying, how would you tell which one?
Oh, it's curved.
So if it's a graph, if it were a graph,
I said that.
You said that. I knew somebody said multiplication and somebody said curve between you two. If it's a graph, it's a curved line. If it's exponential, it's a straight line. If it is linear. So if it is a table, that's when we have a pattern of multiplication, but it is only in the y values. The x values are, for this class, the x values are just always going to be going up by 1. So you got to look at the y value. If there's a pattern of multiplication, that is exponential. If the pattern is addition, you're adding the same number of times, that's linear. What's the third way? What's the third time we might have to tell? So there's a graph, there's a table, and there is
the graph. Wait.
The
wording. No.
Stop saying wording, bro.
You're in your own space, my dude.
Oh no! So now we're just going to go back through every slide we've done.
Oh, okay.
For exponential.
Okay.
Wow.
I know, we've done a lot. That's only day 4 and 5 right there. Oh, there's what division is.
Yeah, I don't know any of this.
That's why we're reviewing.
Oh, yay.
That's the point of a review, because I know you guys forget stuff.
No, it's because I just wasn't there.
All right, here we go. Skip that. Skip that. That is what we need. If you have an equation, what are you looking for in an equation?
Ratio.
Oh, damn.
Josh.
You're just being me today, ain't you?
You're looking for one thing and one thing only. Anybody ever? Oh no, this is before your time. Heroes. I'm trying to use telekinetic power to move her phone into her backpack.
I don't think you.
Yeah, I wish I had. That would be a cool power to have, to be able to move things with your mind.
Oh, I would have done so many things by now.
I'll be in bed right now.
That is the one and only thing right there.
I would really just
Continue.
You can jail for sexual harassment.
So here is the one and only thing you're looking for to know if it's exponential. Ladies, gentlemen, this way. If you have a variable as an exponent, really just going to be x. I'm not going to make it a different variable just for the exit ticket. If you see an exponent of x, again, not just an x in there, because there's an x in this. If the x is an exponent, it's raised up above, that is an exponential function.
Exponential.
That one doesn't have an exponent of x, so that's linear. That one does, so that's exponential. Simple as that, if you have an equation. In a table, we talked about for a table, you look at the y values, pattern of multiplication on the left, that's exponential. Pattern of addition on the right, that's linear. And again, we don't look at the x values. That's where those are scratched out. We're not worried about what's going on with those. Those are typically just going to be going up by 1. These are what we look at. Now, they could be going down. They don't have to be going up. We could be multiplying by a number less than 1, and that would make these numbers get smaller. We could be adding a negative number. That would make these smaller. Doesn't change the fact that we'd still be exponential over here and linear on the right. So just because the numbers are going down doesn't change anything. It's a pattern of multiplication or a pattern of addition.
Multiplication.
Yes.
If you say that word enough times, it starts to sound silly.
It's not what?
Multiplication, like say multiplication like 100 times. You're
Multiplication.
like, that word just sounds dumb.
Multiplication. That's why I like talking in British, because it's just,
All right, so here's the next thing you need to know how to do. Now let's say I give you something, I say this is a exponential function. So I tell you it's an exponential function. And I say I want you to write the equation for that exponential function. Here, I'm going to zoom out a little bit.
So the exponential function is going to be the one with the raised exponent? Or no?
Yeah, but I'm telling you now, this is exponential. Like both of these, right and left. They're both exponential functions. I then tell you though, I want you to write the pattern or the equation. Not really formula, equation is better. This is the equation right here. Remember we did that f of x equals a times b, and then the b was raised to the x thing. Actually just showed it on the other screen too. A was the y-intercept, or sometimes it'll be called initial value. Like if it's like an investment, your initial value is your initial investment. We did that thing where we invested money and figured out how much we would have at the end of the 40 years or whatever it was. A, how do we find that from a table?
How do you do the equation? A.
The A value, like we're gonna write this equation.
When x is 0.
Yeah, it's kind of already highlighted. So the A, so you need to be writing this down right now. This is where you tune back in and write something down.
Yes.
When so write that equation down, write down that's the y-intercept, the B is the pattern, or it's also called the constant ratio.
When you're
I'll let you guys get caught up.
F.
What happened?
Oh my
Top
God.
number. Hey, Mr. Gill, did you know that a hot dog is technically a sandwich?
I'm gonna get some water.
Not the sandwich.
Mr. Gill.
Go quickly. There's a line. Come back.
it out. I'm trying to figure out how.
Don't be out there. I mean, you're missing. I guess I'm. You're the one missing the review. So. All right.
The pattern. Oh.
No, we're doing a hot dog.
I know a lot of my
Technically
teachers
a
talk to me
sandwich.
back in British all the time. It's so funny.
I used to know a lady that lived. She was born here, but she lived over there for many, many years, and she would go in and out of her accent. What? What did you say? I didn't answer you. Why did you say thank you?
You said it was supposed to call me. The equation. So how many weeks do we have
Where
left?
do you guys go when you just completely tune out? Like I said like 3 or 4
I go
times.
into line.
Thinking
Why
Sure.
am I?
I think about life.
I like thinking about Minecraft.
All right, so you should by now have at least copied down the generic formula.
I'm always thinking
So
about
when are
my
you gonna
So-
post it? When? What?
I'm about to go.
Alright.
As soon as everybody writes down. So, there is a question where I say, here you go. This is an exponential function. I give you a table. And I say, I want you to write the equation, the exponential function equation, whatever you want. So this is the generic version with the variables in it. You're then going to have to find out, well, what numbers are going to replace that A and that B. The A is the Y-intercept, which you should have written. How do we find the Y-intercept again from the table?
X is 0.
You find where the X is 0 in the table.
Yeah.
The Y-intercept is that Y value. Now, if the table is not vertical, be careful what you choose, because on the last exit ticket we had, I guess I'll show it to you right now. I was going
Can
to
we
get
use
to
our
it.
notes for this one?
Yeah.
Oh, we can.
So here, if the X is 0, I don't just choose the number to the right of it. I choose the Y value. The Y value is down here if the table is horizontal.
Yes.
So that's the value that would be the Y-intercept. So it's not just the number to the right, it's the Y value when X is 0. So you got to be careful if it's a horizontal table. Whoop. Wait. Same table, I think. Huh.
Wait.
Well, I'm not on that screen. Here we go.
No, we're right now.
No, I'm on the same screen. So that should be pretty simple to figure out the A value. I don't make it hard. I don't, like I was going to make it to where I didn't even give you the line where the X is 0 and I made you figure that out, but I didn't even do that. So you just pick the Y value when the X is 0 and you put 5 or whatever the number is in the equation. So now you got to figure out the B value. What's the B value?
3.
Pattern.
It's the pattern. What are we multiplying by every time? Now in this one, it's pretty easy. You just throw numbers out. What did I multiply to go from 5 to 10?
2.
What did I multiply to go from 10 to 20?
Very much.
So 2 is pattern.
Yes.
So my number would be 2.
X and Y.
Now, what if it's not as easy to find that pattern number? What if I give you, like I did on the last exit ticket, I gave you a bunch of decimal numbers.
You divide. You divide.
You do all of that, what both of you said.
Yes.
I need to take any two numbers, doesn't matter what two, if I've already told you it's exponential, you don't have to test them out. The pattern's gonna work for every two numbers. Take any two numbers and you take the bottom number. You take the bottom number, so 20 will be the bottom number, I'll do it in a second, divided by the top number. So in this case, I would do, I guess I'll write, I would do 20 divided by 10, because again, 20 is the bottom number. Kind of weird, the bottom number actually goes on top. The top number actually goes on the bottom, so I think that confuses some people, but again, if it confuses you, then write some notes around it. Tell them, say, start switching or something, whatever you got to do. So that would have given me what I kind of already figured out on that one, that the pattern was 2. But on one where it's a little trickier to figure out, like, what do I multiply times 10 to get 15, or times 15 to get 22? That's when you're going to need to use that formula. So you would say, again, circle that, bottom number divided by top. That will give you the B value that you need to use in replacing the formula. So the formula for this one would be what? Real quick. 15 divided by 10 is 1.5, by the way. So what's the formula for the one on the right? We did the formula for the one on the left. What's the formula for the one on the right?
10.
10 is the A value, because again, X is 0, we pick the Y value, so the A value over here would be 10 times what?
1.5.
And then 1.5 is the B value. If you're not getting this, I'm not going to slow down, because we've done all of this. You can go back and watch it.
What?
So 15 divided by 10 is 1.5. That's the pattern. The pattern is the B value. The A comes from the Y-intercept, which is just wherever X is 0. What is my Y value? Well, 10. 10 is the A for the equation. So you'll have one, I don't know if I'll put a bunch, we already been quizzed on that, so I won't put a bunch of those. Your last exit ticket, you had to do that a few times. but it'll be on there. We just did all that. Oh, wait. No. What kind of equation is, or what kind of graph is that? Exponential growth or exponential decay? Growth, that the values are going up. So if you look at a graph, and if as my x values get bigger, meaning I'm going to the right basically, if the y values are also getting bigger, that is growth. And if it's curved, it's exponential. So that's exponential growth. Now if I had this equation, that would be exponential decay. As my x values are getting bigger, the y values are decreasing. They're getting smaller and smaller and smaller. So the blue line would be exponential decay. The red line is exponential growth. If you have a table of values and you're trying to figure out what it would be, again, the values would just be getting bigger for the y's if it's growth. The values would be getting smaller for the y's if it was decay. So same concept, it's just a table versus a graph. And there are a few questions that are, I consider to be some of the easiest questions on there where I just say, is it growth or is it decay? All you gotta say is growth or decay. And then I'll show you the other super easy ones when we get to the end of the review. What?
We have free time at
Oh, the exit ticket?
the end. The exit ticket today?
No, I'm asking you, free time at the end of what?
Today.
No free time on a review day. We're gonna get through as much as we can for the review. After this, though, you don't have any more big stuff, so next week you should have probably every day, so a little bit of free time. I'll see you 3 times next week, so yeah, definitely. But no, on a review day, I want to make sure I cover as much stuff as I can. We already really did that. Again, what's the pattern? What would my B value be? So again, this is the formula. What is the, actually just do the equation. Everybody don't yell it out, do it. I'm not going to walk around and check, but it's for, this is for you to be able to do well on the exit ticket, so
We will.
you might as well try it. Because if you get it now, then you should be in good shape for the exit ticket. So you need to figure out what is the A value, what is the B value. Yeah, if you need a calculator, you might be able to just guess.
What's the rest of the 5?
You don't need the rest of them. Those are the easiest 2 to use right there. Remember, you only need 2 of them. All you need is 2 numbers to do the pattern. If you were trying to figure out is it exponential or not, then you would need all of them. But I'm telling you that is exponential, so you just need to figure out the pattern. The only time you have to test all the numbers is if you're trying to figure out whether that means. I'll write it down. I'm going to walk around in a minute and check a few, but I'm going to keep moving forward.
Oh crap, I need a calculator.
Got it.
Yeah.
Sure, calculator.
Calcs. And, oh, well, that's that. Oh, and there will be a lot of partial credit. So if you're struggling with some of this, all of you better be able to find the A value. Like at the very least, you better be able to get the A from that table.
All right, here we go.
If you have trouble with the pattern, again, you should still, I mean,
Mr. Gill,
You
I'm
still
going with
gotta get
Candace
that.
after school.
All right, here we go.
What?
I'm
So,
going with Candace after school.
how's she doing? You know, I can't even tell you what she told me the other day.
Uh-oh.
Speaking of after school, I will be staying tomorrow and doing another review. So doing like a couple problems tomorrow after school for the exit ticket on, for those that you want to come in tomorrow afternoon. Yeah. So yeah, if you want to come in tomorrow after school during lunch, I'll probably,
How much more extra tickets do we have after this one?
probably just one, and that'll be a smaller one, so.
So I'm gonna come study that part. My greatest day.
Yes, good.
I know that was right.
But you don't need to drop too many.
Oh, I figured you did.
The only thing that needs to be dropped
All right, so what's the answer?
Times 0.5.
You could put a fraction. If you made it, that's fine. As long as it's the correct fraction.
I did a fraction.
So it should be 1/2 if you did a fraction. Or if you did a decimal. So it could, either one of those is correct.
I forgot to put the A.
The 1/2 is fine. 1/2 is the same thing as 0.5. Don't forget the x, because that is part of the equation. All right. So again, hopefully you're at least getting part of that, but really, I mean, that's not super tough. You should be able to get both of those pieces. If you're taking notes, you should be able to. So we just kind of did all of that. We might come back to it. Here, I'm going to zoom in on that because I do want to ask you this question. I don't think anybody's gotten this right yet. So here we go. We have an equation up there. What's the y-intercept? The a variable.
1. No, 8. Okay.
1? No, the top one. Number 1.
8.
Not the table.
8.
8 is the a variable or the y-intercept. It's not always the first position, but I normally do put it there. It's the one that doesn't have the exponent, basically. So what is the b variable or the pattern? Just the 9, not 9x, just the 9 is the pattern of the b variable. What's it called? What's the math term for it? Constant ratio. Remember, when we move into geometric sequences, they call it the common ratio. They're the same thing, really. Let me ask you this. In the table below, is it linear, is it exponential, or is it neither? And if you think it's linear or exponential, what is the pattern? Like, what's the constant ratio or the constant rate, depending on whether you think it's linear or exponential? Well, you just need to answer, is it linear, is it exponential, and then explain why. I don't know. I'm telling you what you need to do. Is it linear or is it exponential?
Can I just split my number?
It's linear.
Here.
Is it neither?
I don't know.
I think it's neither. I think it's, it could be neither.
I mean, neither is an option. That is an option that you can choose,
That's
one of the
kind of
3.
hard. Actually, I can do this one.
Well, let's talk about it. Is there a pattern to it? Let's try to find a pattern. Is there a pattern?
I don't think so, no.
It's not why.
Well, let's see. What are we doing? Again, we don't worry about the x's. We worry about the y's. What are we doing to go from 1 to 1.1?
Never mind, I missed one. That was one of the wrong ones.
What are we doing to go from 1 to 1.1?
Divided by? Oh.
Well, no, we're definitely not
2?
dividing.
Oh.
No. How can we get from 1 to 1.1? It's only 2 ways. Could multiply. What are we multiplying 1 times to get to 1.1?
The x. No, that's add.
Oh, you
Why
multiply
that?
by fraction.
Let's add.
Bro, Mr. Gill, I was doing the wrong thing.
How do we find the pattern? We just went over how to
On the
find
number
pattern.
on the side of it? Top over bottom.
Well, but what happens when it's horizontal? It's not vertical, so we got to do what?
Multiply, or divide.
Bro,
Divide what? You
Take
say
the
it like
1.2
every possible.
divide by 1.
You could. We could take these 2. Now we would say the right divided by the left. So somebody do that. We
I
get.
got 1. I got 0.909.
I got 0.1666667.
Really? Oh, yes.
That actually continues forever. So if I take that number and if I multiply that times 1, do I get 1.1?
No.
I do not. So multiplication didn't work, did it?
Nope. Division.
So the only other pattern could be based on, no, division, there's no pattern based on division. Only other pattern could be based on addition. So what am I adding to 1 to get to 1.1? 0.1, right? Do I add 0.1 to get to that?
Yeah.
Do I add 0.1 and get that?
No.
Oh, so that didn't work either. So neither of them work.
How was it? It's linear.
No, you weren't.
Really?
Is
I
it,
was
there is
right,
pattern.
but I said it in my head.
Here's the thing. Here's what you need to remember. This is more for next year. I might put a little something as a bonus question on there about this. When you go to find, what did I say about the X values earlier? That they'll always be kind of doing this in this class? I make it pretty easy in this class. The X value, well, the X values.
Do you know you could color on a calculator?
What's true about X values from all these tables?
They go by one.
They go up by one, don't they? 0, 1, 2, 3, 4, 5. But what about this table?
Oh.
Are they going up by one?
Not the same one.
So if you are trying to find a pattern for linear, exponential, it doesn't matter. You only look at the values of X that are going up by one. So we ignore all
Makes it easier?
these.
Does that make it easier?
Well, no, that's you just look at them. That's the only ones that you look at when you're trying to figure out a pattern.
So it's
Now is there a pattern?
What happened?
Well, what's the math though?
4 divided by something.
No. I mean, what are we doing? The 2 is right, but we're doing what? With, are we adding it? We're multiplying, right? 2 times 1 is 2. 2 times 2 is 4. So we ignore all of these
So can
decimal
we only do this for
X's.
these ones?
So
Or
can
we
we
do
do
it
that or no? Or
Can we do what?
That.
for these? Look
You
at
have to do that. Well, that's what I'm telling you. If you're trying to find out is it linear or exponential, you have to ignore any X values that are decimal. Or if you,
I'm gonna write it
or
down.
if you skip X values. Well, don't worry too much about this. This is not going to be on the exit ticket, other than maybe a bonus. What if I would have gone from 0 to 2 and then 3, 4, 5?
No.
I would need to figure out what the one value of X is and Y and put that into the table. You have to have your X values going up by 1 every time. That's a key to a table. Even when we did linear equations, we talked about that a little bit in those. You have to have the X values going up by 1. It's the only way you can figure out whether or not there's a pattern. So we already talked about all of this. Pattern is the bottom number divided by the top number. Y-intercept is the Y number when X is 0. Oh, this would be an example of when I didn't give you an X of 0, I was going to make you do something like that. You would have to then say, okay, well, I need to go up. No, let's make sure we have time if you really want to, I guess.
Okay, we'll try it.
So if you want to, I might make this one a bonus. I was thinking about doing that. So I'll zoom out.
The bonus
So
is already gonna have it in my
try to
notebook.
write the equation for that table. Again, I would only make it a bonus because we haven't done anything like it. But you could probably figure that out, I think, maybe.
5.
Oh,
So can you
it's
start
adding.
with the top and bottom from these? Or-
Well, the pattern is, nothing changes when you go to find the pattern.
Okay.
It's the A value that's harder to find this, because I don't give you a line where X is 0. So you can't just look at the table and say, oh, there's
Oh, I
X is
remember.
0,
Wait, when it's not 0.
and then there's my Y value.
I
So
forgot.
you gotta
Did it
figure out
right.
how to do that.
I forgot. It's my other note. Okay.
You forgot how to
I don't know how to do this.
Yeah, that's what I'm saying. If it's
I
not
don't think
0.
I might have done this one, I don't remember. to
divide
be
by the
honest.
pattern.
I decided not to put on the exit ticket because
Yeah.
we didn't do it a lot.
Yeah,
Didn't we
yeah,
just-
yeah.
We been
I'm
all
smart.
this, Mr. Gill.
Don't you divide by
Okay.
the pattern?
Well,
From
then
the
do it.
bottom to the top. From
Yeah.
this one, that one, that one,
Then
that
it
one.
should be easy.
Okay.
Oh my God,
Learn
it's
the
a lot.
pattern.
Mr. Gill, your hand is in the way.
Your hand is in the way, Mr. Gill.
There.
I'm so
Hold on, I have, wait.
Mr. Gill said.
What?
Sorry.
It's cursing at me.
I'm talking to him. Oh,
Oh, I know you weren't talking to me, but still.
don't say
You don't need to
that.
be saying that.
That's illegal.
You guys need to learn. I hope you can control when you say that kind of stuff.
That's very much not right.
I have some students that cannot.
Doesn't
Like,
match
they
the
literally
pattern.
don't even know they
That's,
say
that's,
it.
that's very bad for angry.
That's bad. Like, that's not a good habit to get into.
I have angry.
Because when you're on the
Linear.
job
Linear.
and you do that, even if you don't get fired for it, you're still going to be looked at differently by
This is
an
the linear
employer. You can't
equation,
control your
skills.
language.
Linear. 'Cause I
It's a
multiplied
diagram.
it.
I got it.
It's like,
Linear.
give me the
No,
diagram.
this exponential, this is right.
It is.
You
Miss Gill.
What?
What do you mean? I work too hard.
I'm teaching.
Can you check mine?
I'm about to do it right now.
Wow.
What do you need?
They would have do.
You just need to go?
They would do.
Bathroom?
do.
Are you at my checking time?
Oh, snap, no, just go.
I don't even know where my, oh, they're in my hand. Duh.
Nothing.
Are you working on this one?
Yeah.
Oh. No, it's not. How did you get this one?
Way.
How did you get the 1/2? That's kind of close, but 2 times 1/2 would not be
What?
2 times 1/2 would be actually 1. There is a half involved. It's not just a half.
I don't know how to do
Something in a
this.
half. You'll see when we go
Miss
through
Gill,
it. Though.
somebody at the door.
Can you use
I
it?
don't know.
No, because she here for
Yeah.
Jasmine.
He's not.
It's like, yeah.
Can you check this?
Whoa, scared
Mr. Shiny.
me.
Kick her out.
Did you get it? I believe you did.
I mean,
We'll find out in a
you
second.
know,
Can you check mine?
Bro.
This question is from the notes.
Yeah, we did it before.
I know you said 0, but there's no 0. What did you say? I forgot.
So we need to figure out what would the y value be if we had the row where x was 0.
Oh, you divide 2 by own.
So we just need to reverse our direction, and we need to figure out what the pattern is, and then we need to divide 2 by that number.
Yup.
That's what we do.
You got get 0.8.
So yeah, the correct answer for that would have been 0.8. So the formula you should have come up with would have been 0.8 would be the A value. The pattern is 2.5 because that we just do like any two numbers and you say bottom divided by top. And then X is just X.
That's
So
very.
that's, again, I'm not expecting you to be able to do that. I mean, I might put it on there as like a bonus, but
Stay saying that.
So we're supposed to get rid of, so we're supposed to get rid of the thing that doesn't make sense, and then continue on with the problem?
get rid of the thing that doesn't. When
Wait,
did
why
I
is
say
it-
anything
wait,
about
wait,
getting rid of
wait.
something that doesn't make sense?
2 times 2.5.
Big fella, straight.
Can you show me how you got 8 again?
2 times, the pattern is times 2.5. So times
Oh,
2.5. That is times 2.5. That is times, that's the pattern. I'm multiplying by 2.5 every time. That's the pattern. And the way I would have figured that out is, again, bottom number divided by top number. 12.5 divided by 5 will give you 2.5. But if I'm trying to reverse my direction and figure out what would be above the 2, I got to reverse my math. I got to change that to divided by 2.5.
okay.
Okay. Again, I don't expect that to be
No, because I need
like
to.
a big important part of the quiz tomorrow. So if you get it, if I put a bonus on there, then you're in great shape. If not, no big deal. What is this particular equation or function? Exponential or linear?
Exponential.
Yeah, there's an x as a variable. That is exponential. What is this one?
Linear.
Linear. There's no x as an exponent. What is this one?
Exponential.
Eh.
What?
No, that's linear, it doesn't have the
I
X.
don't.
5 squared becomes 25. I got rid of the exponent.
It's because it doesn't have the
You don't know what
X.
5 squared
That's
is?
another way to find out the
I
X.
didn't know 25 had like that. I was two separate kids.
Well, it's not. I mean, this is just equal to that. So if you,
Now you're telling me.
my point is, it has to be a variable. The exponent has to be a variable of x
Oh, okay.
in order to be exponential. Next year, you'll get into a lot of other stuff where you deal with
I don't even
exponents.
want to think about next year's stuff.
Oh, you
Next year.
really don't. You really don't want to think about next year.
I love how you're stressed for. I got chemistry next year. I'm like,
Oh, I love chemistry.
don't do that.
Are you
Get it over with.
Are you gonna be for next year's
Dollar?
Are you doing
I'll teach this set. Well, actually, I might have geometry, so I might have. No, you guys will all be in algebra. I won't be teaching algebra. I'm pretty sure. We've already done that. All right, let's go through this real quick.
You won't do 10th grader math?
Well, I'll have a different 10th grader math than what you'll be in.
I'll probably be there.
Because you guys will all be going into Algebra 1, and I won't be teaching Algebra 1, I'm pretty sure. All right, so here you go. Let's go through these real quick, just some definitions, kind of. I do have at least 3, maybe 4, like understanding questions, like where you're not solving anything, I just ask you a question, you have to explain it.
Do we have to do
I
this?
really need my glasses.
What,
I know you see me doing this to you all the time.
the positive number that is repeatedly multiplied by the initial amount in an exponential function is the?
Didn't we already do that?
Constant.
We did all of this, yeah, it's all review, that's what a review is. We go back over the stuff we did.
She's, can you put it down there?
So, if I am multiplying by a number over and over again, that number is the constant ratio, and it means that it's an well, it tells you here. It means it's an exponential
Ratio?
function because the pattern is
I like
1 to
that word, ratio.
All right, so I'm skipping to a pattern of growth with a constant value added is what?
Ratio.
A pattern of growth with a constant value.
Oh, wait, what? Oh, I didn't see that.
Constant.
I don't know.
What is here? A pattern of growth. Oh, exponential.
Yeah, growth, but that's not what growth.
Exponential.
What's the key word in there? Growth isn't the key word. You can have all kind of
Because
growth.
growth is a key word.
Constant
No.
Didn't he say growth? No, it can be decreased.
Yeah, there's another key word though.
Constant additional amount.
No.
Value.
Added.
Hey!
Oh my god, no one cares. I got it right, I don't care.
So why is that important?
Adding.
What pattern is based on addition? What kind of function is based on a pattern of addition?
Linear.
Linear. We can still have
Oh my
linear
god, so
growth.
the next one's
This is
exponential.
linear growth right here.
The other
As
one's
my x values get bigger, my y values are also getting bigger. That's
That's
still
what I was
growth.
thinking.
Yeah, you can have exponential growth or linear growth. Exponential growth just means it's curved. Linear growth just means it's a straight line as the y values get bigger.
The next one's exponential.
So now that's the key word right there. So for pattern of multiplication, that's exponential.
Is the constant ratio? Is the constant ratio for the,
Number 6. What's number 6? What kind of function is that?
Exponential.
Yeah, again, key is we have an x there. Oh, actually, number 6.
Mr. Gill,
Yes.
I think we get it. I think
I
we
can
get
go
it.
to the bathroom.
You just went out and got one
I'm gonna go
earlier.
get some water.
That's going out. How many breaks do you want?
Just 2 times to
Just
go get
two.
some discount Doritos, that's it.
Go, Mariah.
Number 7. Number 7. What kind of equation is that? Number 7.
It's exponential.
Numeral, how do you say 7?
Those the way it's-
Numero 7.
That's linear.
No x is an exponent, right? So linear. In the function y equals 5 raised to the x power. 5 is the what?
Exponent.
5 is that in much?
No, that's completely
That's
totally
very
wrong.
wrong.
5 isn't even an exponent.
Oh, it's an A thing.
Maybe. But you gotta use those words up
Oh my
there.
god, this class is so dead.
Oh, the S, no.
Sorry.
No.
Exponential.
Wait. What you said?
Linear.
Constant ratio.
You are guessing everything wrong. Statistically, that's hard to do. Number 8. What is the answer? Number 8.
Linear.
Exponential.
No. It's asking you what is the 5.
It is the constant ratio.
It's not asking you what kind of function it is. It's asking you what is the
ratio.
5.
I don't know. I'm just kidding. Sorry. 5 is the asymptotic.
No.
What does that mean, by the way?
I
Oh, I was right.
The 5 is the b, because remember the b is raised to the x power.
I'm the only one who said constant ratio, by the way. Just saying.
What do you got? Oh my goodness gracious.
Mr. Shiny, what is the first one? You have no business being in this class. You never come.
Oh. We're also in math too. We're in math too.
Mr. That's where you had the football game. Mr. Gill is a fire.
Mr. Gill, you should be bullied.
So constant ratio, again, this is the B value. In the equation, here, B is raised to the X value, and then it's being multiplied times A. So whatever number is raised to the X is the B, which again is the constant ratio. Let me ask you this question, what's A in that same equation?
A. Wait, what?
What's
One.
the A? What's A equal?
2. In that equation on 8?
Yeah.
What? 5. What did you say? 5. That's it?
B is 5.
2.
Okay.
2.
We just said B is 5.
Oh my God.
B is 5. You just said that. 5 is the constant ratio. That's that.
2. Why? Wait, I'm confused.
Why?
Why is it not 1?
Again,
Again.
you guys already enough chatter going on right there, so don't let me hear that too.
Because wouldn't you put 5 in
We
that?
don't want to go with a third strike. What?
Is it A, Y? It's 1 with the X on top. Why would it be?
No, it would be Y equals A times B to the X. I just didn't write that in, so I should write that in.
Wait, that doesn't make sense.
F of X. So it'd be F of X
Is it 25?
equals there.
0.
What is the value for A?
1. Not 1. 5.
No, because if we multiplied 0 times, it would always
You're not
be
listening to
0.
this side. You're not listening to me.
I've already said twice that you.
Is it 25?
Then they're not listening to you.
I don't care.
Where are you getting 2 from? Because you're pretty sure about that 2.
What'd you say again?
I don't know. The times that
Oh,
are
yeah.
4. I said that.
I
You know what?
I know
Well, I did, and then I said 1.
I didn't hear that.
Shayla said 1 too. But she
Yeah, I said 1.
Shayla said 1.
I said 1. I did.
You did?
Yeah.
Alright.
I said
It is 1.
I said Y.
Okay,
Why
so
you
you
gotta
need
mess
to
with us
write
like
this
that?
down. If you didn't know it. If you do not have an A value in the equation or in the formula, whatever you want to call it,
If
however you
you
think of it.
do not.
Like in this one right here, we just have one number. And that number is being raised to the X power.
Have a value.
So we don't have a
One.
second number,
It's 1?
then A is 1.
Okay. 1.
Not till she gets
I'm
back,
really
or not
kindergarten
until it's
right
been a
now.
little while. So again, if you don't, we've written that before, so it should be somewhere else in your note.
What happened?
Oh,
Uno, dos, no tres.
so Joe, what's my A value in that equation?
Yeah, Joe.
What's that?
Stop putting it on your phone.
Put it in backpack. Because I sat there and watched you play with it for a few minutes and didn't look up. Bad decision on a review day to do that. Well, I wonder why. You're playing on your phone.
That's so.
Don't then throw that out. Oh, I know. Do a lot.
Mr. Gill, don't worry about them. Worry about us girls. We're the ones that are working.
Everybody.
I'm working. They never work. Are them?
She came back.
Oh yeah, worry about us girls.
I'm working too.
All right, here we
You're
go.
good. You're good.
Us girls.
So that's everything on that one. He's just going back. On number 4, is that exponential growth or decay? That's easy. It's curved line, and line values are going up.
That's you.
On number 5, is that exponential growth or decay, or linear growth or decay?
No. No. And decay. Wait, no, it's not. Linear?
Is it linear growth or decay, or exponential growth or
It
decay?
depends where you're going. Exponential growth and decay. Growth.
Can't be growth and decay.
What do you mean?
You can't have growth and decay in the same table. I'm talking about number 5.
Exponential growth.
Well, I thought you were talking about
that
one.
I don't know.
Exponential growth.
Oh,
Why do you
yeah, it's
say it's
exponential
exponential
growth
growth?
because it's multiplying by 2.
Oh wait. Decay. Fine.
So you just flip-flop, just like that.
No.
She talked you right into it, huh?
No, I'm
It is exponential, so I think we established that.
It's
Is it growth or decay?
growth.
Growth. And this is
We're talking
Because
about
it's a
one
pattern.
system.
I know what you're trying to do. It's growth, decay. Wait, no, it's growth,
It's
growth, and decay.
How do we tell growth versus decay?
If it's sloping downward.
I feel like
I'm talking about 5. There's no graph. I'm talking about 5.
Oh, if the numbers
5
are
is going in the middle of the table.
if the numbers are going down.
Decay would mean these are going down. These are not going down.
Yeah, they're going
These
down.
are getting bigger.
So right.
I don't know. You said like 8 things.
Wait.
You said both. You flip flop.
No, I didn't. I was just saying that. So I can.
She talked you right into
No, I was
decay.
being goofy. I was not being for real.
Grow.
Yeah, exactly.
If the Y values are getting bigger, that's automatically growth.
That's what I said. That's what I said. See, it's not freaking decay.
Number 6 is decay.
It sounds like you're trying to sing that commercial.
Again, though, you can have linear growth and linear decay.
That one's decay.
That's possible, but then our pattern would be based on addition, and these numbers would be getting bigger, but we'd be adding the same number every time.
What if in the X column there was like, instead of the 3, what if it was like 1?
Then it wouldn't be anything. It wouldn't even be a function, actually. Because if we have a 1 here and we get 10, if we have a 1 here, we better get 10. Can't get 40. That was how we determined if something was a function or not.
You didn't ask what the last one was.
Yeah, we did. We went over it. It was decay. The last graph was decay because the Y's were going down. We already talked about that. Oh wait, maybe I'm zoomed in too much. Yeah, I am. Okay, so we do have to go over this second one. If I ask you what I asked you right there, so if I say solve for f of x when x equals 0, what's that mean?
Wait, what?
If I say solve, just what it says here. So in the equation, I talked about the equation above. I want you to solve that for x equals 0. What do you do? Same thing that I would ask you if I said evaluate for x equals 0. Same thing.
Exponential.
It's what?
Don't even know where you
Okay,
No, it's not 1. That's
do
a
you
very
mean, like-
common answer.
a number or what do you do? 8.
That's the answer right away. Literally up on the board. All right, so here, let's go over this because you will see one of these on there. If I say evaluate, all that means is plug the number in and do the math. That's all evaluate means. So if I say evaluate for when x equals 0, or if I say solve for when x equals 0, I'm just taking this equation. So that's the equation. It's got a variable of x in it, right? But I just told you x is 0. I'm telling you right here, make x equal to 0. So all I do is I just plug in 0 for x. 8 still comes down, the 9 still comes down, but instead of x, I just make x 0. And now you just do the math. What is anything raised to the 0 power?
0.
Oh God, somebody said it. No, it's 1.
Oh.
1 is so long.
If this is 1, I still have to multiply that 1 times the 8, so I get a final answer of 8. This is what evaluating or solving when x equals a number means. You just plug the number in for x and then you do the math. Hopefully you can do the math. So we're going to show another one of those in a minute. Maybe now. Oh, nope, that's what division is. That's not on the
That
quiz.
looks like a mouse.
That was what division was. Go. Why didn't it work? Go.
What's that? Why haven't we done that? What's that?
Which one is linear? Which one is exponential?
Exponential and linear. Yeah.
Correct. X is the exponent, therefore that's exponential. Here it's just x times something. There's
Or
no
that one could be it.
No.
I'm just saying.
No, it can't be. Don't even confuse me.
What if you're trying to trick us and that one wasn't supposed to be?
You guys try to read too much into me tricking you. I don't really try
Because
to.
you do.
Hey, we do bad enough already without me trying to trick you. So
Alright.
I'm not trying
That's
to.
fair.
Now I'm not saying there aren't going to be some harder questions, but I'm not trying to trick you on it. All right, so we already talked about what a graph looks like if it's exponential or linear. We talked about equations. If you have a percentage and it says you're increasing by a percentage or decreasing by a percentage, like in a word problem, that would be exponential. Increase, because you're not going to just have a pattern of adding a percentage. You're going to multiply times that percentage. So like when we saved money and the interest rate was 10%, we multiplied by 1.1 over and over and
Should
over.
we write this?
If you don't know it, I would at least copy this down. A percentage in a problem means you're gonna have a pattern of, again, this is specific to this lesson. I'm not saying every time you see a percentage in math, that means it's gonna be an exponential
But for
function.
this test, is that what it's gonna be?
But yes, for this lesson, this
Okay.
topic, meaning this exit ticket in 2 days, if you see a percentage, that means you're multiplying times that percentage over and over and over.
And then pattern of addition.
Yeah, there's nothing. I mean, pattern of addition, you should know that from a table.
Yeah.
If you, again, have this function, f of x equals 2 raised to the x, what's your a value there?
Huh?
What's your a value there?
Oh, what?
F of x equals 2 raised to the x. What's your a value?
2.
No.
One.
Something.
Uno.
Yes, it's 1. Because we just said this is the b value, because it's with the x, and we said if you don't have an a value, then the a is 1. Now, if I ask you to evaluate for when x equals 3, that's what this means. You're just plugging 3 in for x. So I plug in 3 where x was here and where x was here. So it becomes 2 to the third. I then do the math on that. 2 times 2 times 2 is 8. So that's what evaluate would mean. You just plug in the value of x, and then you do the math. The thing we're now getting at, yeah, here's the biggest part of the quiz right here. Geometric sequences.
Not the geometric.
Yes, the geometric.
Is this gonna be?
Although this one actually is not geometric. What's the pattern in this one?
3.
What do you mean?
Wait,
What's the pattern? Where the little hops are.
Oh, the hops.
The hops.
bunny hop.
What about 8?
That's how much
Adding
you're
8. Remember, the pattern is always a math operation.
You can
and
see
then
it in the last number.
Now, if I just asked you for like the constant ratio, then it's just a number. But you got to figure out, because there could be a pattern. You can't just say 8 because it could be a pattern of multiplication or a pattern of addition. So here we are adding 8 every time. I'm gonna show it to you. Oh, actually, no, we don't need to do that. So I'm adding 8 every single time, which means this is what kind of sequence?
Linear.
That's not a kind of sequence.
Oh. Sorry.
No, exponential is based on multiplication.
Sorry. I was right though.
It would be linear, you're correct, if we were talking about a function in a table. So what kind of sequence do we say? It was one we did a while back, but then I reintroduced it. Sequence.
Oh,
Sequence of numbers in a row.
1 plus 1.
Oh, arithmetic.
Hey! Did you look it up or do you remember? You looked it up.
It's in my notes.
Yeah, we just did it. We literally did it right there. So arithmetic, now, I'm not going to put a bunch of stuff on this because we already tested on this a while back, but there would be probably one question where I ask you something about arithmetic sequences. Geometric, though, is the one that we just did. So there's going to be a lot of stuff on that. A geometric sequence means that we are multiplying by the same number every time to get to the next term. Multiplying by the same number every time to get to the next term. So what are we multiplying by to get from 140 to 70?
It keeps spacing out.
140 times 2 is not 70.
140 times 2?
Can't say dividing. Oh, you caught yourself there. No, can't say subtracting. No. No.
Okay, wait, say that again.
No. I know. What are we multiplying by? Put the food up.
Wait, what question are you
I said, what are we multiplying by to go from 140 to 70?
0.5.
140 times 20 is 70?
0.5. 0.5.
Don't you just.
You just said 2
That-
minutes
that-
ago, and I said
do you do
no.
something?
140 times 2 is 280.
But well, you're going down.
I know, so
0.5.
we can't be
It's
multiplying.
0.5.
Oh.
He actually got one right, Tyler.
Yeah.
Because if you did not, you liar! You just make up and you see.
I said like something.
I can't see. You know I got, look,
I
can
remember
barely- can barely
because
see
I was like, wait,
the
so I have to take
calculator.
half
What's the answer?
away.
Let's
And I thought, oh,
calculate.
1/2. What's 1/2?
So how would we figure it out? What's the formula? Or, yeah, formula, I guess.
Divided by.
We circle two numbers, and we say right divided by left. Remember, you gotta remember that. I mean, hopefully
I've
you
got
gotta remember.
all over my book.
So that value is the pattern, or more specifically, it's that number right there. It's that variable.
All right, I got 2.
With 1.5.
So,
Okay.
So if you are having trouble figuring out, well, let's just go over what this means before I skip forward. All right, so this is the only formula really that's on the quiz. This is on there, but you start with this and then you have to move it into that kind of formula, so it's not hard at all. What is this term? Here's the real tricky part. Let's see how well you're understanding some of this stuff. What does that stand for?
Wait, less on the bottom, right?
Oh, the first term. The first term.
No, that's A1, sir.
The first
That would
number.
be a sub 1.
Would it be the first number?
Yeah, it'd be the first
Well,
number.
a
in the-
sub 1 would be the first term, but I said a sub n, so I haven't given you a.
Whatever term you
The
give us.
exponent.
No, it's the very. It's the very. It's the
Pretty
very.
good. I haven't given you one yet.
No.
R.
No, it's the very first term that's not in the
No,
question.
it's a pattern.
A pattern?
No,
Oh wait, isn't it
No,
how many you
no,
go
pattern
by?
is the R. That's the pattern.
No.
Mr. Gill, isn't it how many you go by?
Kinda,
Like-
sorta.
How many you're going up or something like that?
No, the,
Previous
how many
term?
you're multiplying by is the R. That's the pattern.
Oh, previous term.
All right, so here you go.
Oh wait, I don't know. Never mind.
So let's talk about it.
Everything's too much.
Again, you can get away without fully understanding this part, but the more you understand it, the better off you'll be. So if I have this sequence of numbers, and that sequence would keep going, which one is the first term?
A1.
Well, just in that
Oh,
sequence.
140.
Right, the first position, right? So what's the second term?
Oh,
70.
70.
Right, there's the second term. What's the third term?
Oh my god, just get to it.
So, I could keep going. I could say 5 and then keep doing the numbers and keep going. So here's what A sub n means versus just n. A sub n comes from these numbers. The n value is coming from these numbers. So the n tells you where you at in that sequence of numbers. That's what the n tells you. So that's why A sub 1, I replaced an n with a 1. So it's telling me I'm in the first position. So that's why I choose 140 to go there. If I ask you this question though, what is that number?
A in the fourth position.
So what's the number that's in the fourth position?
17.5.
So
That makes so much
this
sense.
is just 17.5. The n just tells you where you at. We don't really, in all honesty, use the n for anything other than to figure out maybe part of the formula like the exponent. But when it comes to like just conceptually talking about it, all we're really using is these values, and we're using trying to figure out what the a is. We never solve for n. You would be told basically what n is. You only solve for the a value that comes from this. So if I said, I guess I'll do this. I'll do the math for you if I need to. If I said, what is that? What would we need to do?
Divide to the left. I mean, multiply. No. Well, you said something about to the left. Wait, the two first numbers right there. I'm gonna show
Be
you.
more specific.
The two numbers that are next to each other. No.
Where? But I got two numbers next to each other all over the place.
You could do 17, 35.
So what would we do with them?
Oh, divide the two lowest numbers.
Yeah. Maybe.
It could be lowest, but what would that give me?
The pattern.
That gives me the pattern. What is the pattern in this equation? Like which part of it? Which part of it is the pattern? I just mean which
R.
part of this. R is the pattern. I can get rid of that now. So R, let's go ahead. Actually, I meant to do this before I. This right here, this R, that's called the common ratio that's also the pattern. So it was the constant ratio when we did exponential functions. They now call it the common ratio. Either way, though, it's a ratio, it's division. So if we need to figure out what R is, that's when we do the whole circle to number things and write divided by the left. That figures out the R. If I want to figure out this, though, what do I need to do? What does that mean? What am I even doing? What's A6 mean? What am I trying to figure out?
How far down it goes.
I'm trying to figure out what is this? What is the sixth term? Well, how many terms do I know already?
4.
So what do I need to do?
You need to
Multiply.
divide, multiply 0.5.
Multiply the fourth term in the product.
I need to multiply 17.5 times my pattern, which was 0.5 or 1/2. Oh, 17.
Okay.
That'll give me the fifth term, the next term.
375.
Because in order to get the next term, that's actually what this formula is saying. This formula says in order to get the next term, like in order to get what comes after that, I just take this and I multiply it times the pattern.
So confident.
So this times the pattern will give me the next number. And then this times the pattern will give me the next number. All you're doing is just multiplying times the pattern every time to get the next number. So 17.
Oh, 8.7.
Yeah, let me write in and then I'll write that. So 17.5 times 1/2, which is what the pattern was. 70 divided by 40 is 1/2.
I love this math. I love this.
Gives me, what was it, 8.75?
Yeah.
So it gives me that. But is that the sixth term? That's not what I wanted. So what do I have to do? Do it one more time. So do it one more time.
4.375.
There we go. So now that is the sixth term. But watch this. I could have just plugged it all in this formula too. You're about to. A sub 6, what would it equal if I used the formula?
Wait a minute.
140.
First term, right? I just look at the formula. First term is in position 1, whatever that number is, so 140 times, then what?
4.375.
I get the pattern, so I could use 0.5. So if you're going to use calculators, you'd have to use 0.5. So I'll write 0.5 there. Then what?
4.375? Oh, crap.
What else do I have to do? I'm not done writing the formula yet.
So what if it was backwards? Would you do it by the first term then? Instead of
What was that?
Well, I'm not done quite yet. What have I forgotten?
6, the thingy.
The end.
The end,
More
yeah.
specific. Yeah,
I think
I forgot this part. I haven't done this
I
part yet.
said that. So the thing.
Well, but it's not 6. 6 replaces the n, but what do I need to do with that n?
Show me what you do.
Well, what's the formula say? N
Minus 1.
subtract 1. So I can write 6 subtract 1, but ultimately I'm going to want to change that to 5. I'm going to want to do the math and say 0.5 raised to the 5th. So here's what your formula would be. I'll change to red. In your calculator, 140 times 0.5, and again, 6 subtract 1 is 5, so I'm going to raise that to the 5th power. How do I solve that?
What? Oh.
And again, I'm not going to make you do this on a quiz, but I might ask you which first step to solve.
Oh, you just multiply it.
Good Lord, we want that.
Wait, what?
Yeah, you should leave a tip after you've been gone for that long.
Tip?
You've been gone for like 20 minutes.
Is that a
I didn't notice.
All right, what do I need to do? What's my first step to solving that? Because this could be actually, this probably will be a question.
The exponent.
You have to do exponents first. Do not say 140 times 0.5 and then raise all of that to the 5th. So you need to take 0.5 and do what? Yeah, you need to say 0.5 times 0.5 times 0.5 times 0.5 times 0.5. Then you multiply that times 140. Yeah, so that's why I'm not making you do it on a quiz, probably, because even if you know what to do, people make mistakes when their fingers, when they're trying to do it over and over and over again. They try to do it too fast. Is somebody doing it? Somebody's supposed to be doing it.
I was.
Somebody do it. Come on.
Talk about confidence.
Just take your time. 0.5 times 0.5 times 0.5. And then finally times 140. What did you get?
1, 2, 3, 4. Crap, I'm lost.
What did you get?
1, 2, 3.
Oh my, somebody do it, please.
I'll do it.
Class has come to a standstill because we don't know how to
Oh,
use
wait,
a
I did it
calculator.
wrong.
Good Lord.
Is it point something?
Nope. Well, now this part is point something, but then you got to multiply it times 140.
I did.
Oh, then you actually need to. Try it again.
2.5.
0.315.
We don't even know how to use a calculator.
I give up.
No.
Times? 140? 4.375. 3, 1.
Oh, they better come out to be the same number.
You know
You
what?
can solve either way by you just continue to multiply by 1/2, or you could have plugged it all back in. But either way, you better get the same number. That was kind of the whole point of that, is you better get the same number. That could be a question. Oh, I didn't even tell that in the other class, but I like that question too. Yeah, I like that question a lot.
One question.
3.
That's because you were out doing whatever you were doing. I don't know what you were doing.
Okay.
Got yourself all hot and bothered.
Can I use your restroom?
You're in the line.
I-N-G-O.
Actually,
No,
no.
I-N-G-O.
Yeah, but somebody was just waiting. Somebody
I'm not
just,
hurt.
Renaya's out. Yeah, Renaya's out. But somebody, Renaya, and then Anaya. And then,
Y'all going next.
I can't rhyme it. I don't have any other names.
What?
And then
Shania.
And then
Why?
no,
Shania. We can do Shania.
no, me.
Renaya,
Call me in line.
Anaya, Shania.
I'm
You can do
first.
Shakisha.
That doesn't.
Alicia.
Renaya.
I'm first.
Just Naya. I had a Naya. I could do a Naya.
Tell me
I
first.
do have a Naya in my picture. All right, so there's going to be a lot of that.
Just say.
Again, this is geometric sequences, the last thing we did. There's going to be a lot of problems where you're doing either that whole process or parts of that process. And I might say you can solve it out however you want. Like you might just come up with the term by just continuing to multiply. You might plug it into the formula. You might just set up the formula and not even have to solve it out. You might just tell me, what is the B value? What is the A value? What does A to the 6th mean? Like all of those are fair game. So hopefully you got a decent understanding of that. Oh boy, that's a lot of stuff on.
That's too much to look at. Please change it. We're not doing that.
That hurts my eyes.
What is happening? My brain cells are going away just by looking at it.
Oh, I know what you got to do. So here's what you have to be able to do. Let's go to the, yes. So let's go to, that'd be better than what you've been doing. All right, so here's what you need to be able to do. Just like what we did the other day.
This whole class has straight A's, we'll be doing this.
Don't worry, y'all. We just got nice.
Yeah, this is what we have to cover. I don't make up what we cover, you know that, right? I get told what we have to go over. You need to be able to take a sequence of numbers, and you need to be able to do 3 things. 1, tell me whether or not it's geometric. How would we do that? We did that just the other day. We'd have to find out, is there a pattern, and does that
It's
pattern work
multiplication.
all the way through? How would we do that?
You have to just look at something else.
No, you can't just look at it.
Sometimes it works. Right? Well, listen, good
So
method.
again,
Good method.
first step, circle 2 numbers. Let's do one that's a little harder.
Good method. Ow.
Well, what's the real first step? When I circle 2 numbers, what should I be looking for in the 2 numbers?
But what? The actual number.
Well, but which number is
Let me
what I
get it
maybe
out.
want to pick?
I wanna walk around.
Not the fraction.
Yeah, let's pick the easiest two numbers. Like, don't pick, I wouldn't want to pick out of these the 1/2 and the 2, or the 4/5 and the 4. Like, let me just pick the 4 and the 20. Let me pick two numbers that are pretty easy. So now I can say 20, so write the formula when you're talking about a sequence that's left to right. Right number divided by left number. Well, my right number is 20. My left number is 4. So my pattern in that is 5. I'm multiplying by 5. If it's geometric. I don't know yet that it's geometric, because it's saying determine whether or not it is geometric. So I've got to figure that out. But I got to start somewhere. I got to take a pattern and start somewhere.
For that thing, didn't we do like a?
We did all of these.
Yeah.
So if my pattern is 5, I better get the next number every time I multiply by 5. How would we do that with 4/5? Because we don't know how to use fractions.
Decimal.
Yeah, we need to convert that to a decimal.
Yeah.
So I would say 4, top number divided by bottom number, gives me that decimal. So I'm going to get rid of that and replace it with 0.8. So now in your calculators, say 5 times 0.8.
5 times 0.8.
4.
4, got the next number, right? So I got the next number.
What is that say?
What is 4 times 5? Hopefully you can do that without a calculator.
Oh, come on.
So I got the next number again. What's 20 times 5?
100.
So I got the next number. What is 100 times 5?
We've already done this.
So I got the same number. That's why it's called a review.
Oh.
Review.
So I got the same number every single time. That is a geometric sequence.
Go shopping.
Geometry.
The definition of a geometric sequence. You get the same number every time you multiply by whatever the pattern is.
Sorry, you little baddie.
Now let's look at 26. Now we could do the whole right and left thing, but can you tell what I'm multiplying to go from 9 to 18?
No.
Yeah, that's pretty easy. You don't have to do it. Like, just use the pattern that you can see. 9 times 2 is 18. 18 times 2 is 36. So far so good. What's 36 times 2?
72.
Is that 74?
No.
Can we play all around the world
That is
today?
no longer geometric.
So, girl, you know that game?
What?
Do you know that game? All around the world, where you come up with the multiplication number and whoever says it first. Wait, I think that's how it goes. Oh wait, no.
Multiplication problem.
Problem. Okay, you say 5, and then someone starts off with 1, and then the other person starts off with 2 and 5, 3 and 5, and just keep going.
I thought that's what you said.
Not familiar with that.
Like you can
I
play
can't even really imagine. Well, you have to tell me that when, maybe on one day when we do our math break.
Yeah,
we'll
and
play
you think
that.
that's all around the world is? If you get it right, the next person does it.
All right, so the next thing, so that's the first thing you have to do. Tell me whether or not it's geometric. Second thing you have to be able to do is once you know it's geometric, you need to be able to write the formula for it. So the formula would be the explicit formula, which is that one. A1 times R. So again, so here's the only tricky part. If I don't give you a term, if I don't say, I want the formula for the 8th term, or the 10th term, or the 11th term, you just have to leave n as n. If I haven't given you a term, you don't know which number you're trying to find yet, so you just leave n as n. If I give you a specific term, that's when you replace n with that number. But then the rest of it's the same. You take the first number out of the sequence, so we can look at this one that we already did. So the first number would have been 4/5, or if you put 0.8, I'd be fine with that. Then you would say times, so 0.8 would go here, times, so you could put it in parentheses or put the multiplication symbol. R would be what? For number 27, same one we just did. Yeah, so what was the pattern in number
I
27?
think it was 2.
No, that was 26 and it didn't work. It was 5, because we said the pattern was 20 divided by 4. That's why those are circled. So R would be 5. So the answer for number 27, ooh, that's slow. So the answer, if I was to rewrite
Oh my
that,
God, can you go away? That's
point. Oh, I'm gonna write 4/5 because that was in the original problem.
Is it my turn to go?
Oh, I didn't even know you were on the list. Are you waiting?
Yeah.
Yeah, I don't think anybody's waiting.
Gotta hurry up, 10 minutes.
So that would be the final formula right there. A to the n would equal 4/5 times the pattern, and then that would be raised to the n subtract 1. Now, if I gave you a specific number to find, like let's say I said for, oh boy, none of those are great. Y'all?
Didn't we already do all
Yeah.
of
What did we turn you into?
Yes, and that's why it's called a review.
these? Oh.
Yeah.
It's good to know you guys don't listen to each other either.
Wait a minute. Is this right?
I don't see any great ones that give me a pattern that's pretty easy to do, so.
Cuts all of
No, we got one last thing, then we're done. So this is the easiest thing on the entire exit.
Okay.
We did it already, so yes, we did it already. That's why it's called a review. I'll just say that early.
Oh my god, I know that.
I do that.
You are gonna need.
I did do it right.
Wait, which part is it? Oh wait, it's not on this page. Sorry, it's on this page. You're gonna be given a formula that's in this format.
Oh my gosh.
So I'm going to give you a formula in that format, which is the one we didn't do. That's the recursive one.
Oh,
We didn't do
you
that.
know what? Did I did that?
I know.
Totally
That's why I said
forgot.
it's the easiest thing on the exit.
Literally.
I am then going to tell you, I want you to rewrite that formula in a format.
Oh, Mariah
of this.
told me.
Yeah, we did this.
Mariah
That's
taught
our
me
review.
this.
I'm a great.
But we don't have a sequence of numbers, so you can't figure out a pattern, and you can't, like, there's no first number because there's no sequence of numbers. But they give you all that information. Like, you're not doing any math in this. You're just plugging in the numbers they give you in the other formula.
Oh, I think I found it.
So, what is my a to the n is still just a to the n, unless I tell you find it for a specific term, which I'm going to do in a second. So for now, we'll just write a generic formula. I'm not talking about any specific term. What's my A1?
50.
Yeah, it tells me right here. I don't need a sequence of numbers. It tells me the first number is 50. What's my pattern number?
45.
Yeah, it gives me that right there. And then I just change it to n subtract 1 up there. So here's your last thing, and then we're done.
Dang, you really trying to.
On number 9, I want you to write the explicit formula, so that's this thing. But I want you to do it for the 19th term. So you're writing, so here's all the information you need.
Sir. You're not welcome in here.
You have all the information you need right there. You're writing the explicit formula for the 19th term. You don't have to solve out and try to find it. Just write the formula for the 19th term. Once you've done that and shown it to me, I'll let you have your phones out.
Oh, really?
Wait. You know, it's only going to be like 3 minutes anyway, so just go.
I mean, you should be done with this in like 30 seconds.
So what is it?
More than 3 minutes.
No, what is it?
You're writing the explicit formula, so that's that thing that we've been working with.
Yeah.
You're writing that, that's a 1, for this problem. So you're changing this into that format for the 19th term though. So once you're done, raise your hand, I'll check it, and then you can grab your phone.
The ninth turn?
19th.
9 turn? The 19.
Wait, what?
That's because you missed right.
I don't know.
Oh.
That jump won't work with you.
Never mind, I'm not.
19 term. Oh.
I just realized.
Yeah, you got to do it. That's correct. But now do it for the 19th term. All you do is change
Change
one
what?
thing or maybe 2.
Mr. Gill, I need help. Man, I got one photo.
So that would be first. So what's your first term? Let's say 1.
2. And you keep going up.
Yeah. I told you it's the simplest thing on the exam.
But
Is that
what's the
easy?
19th turn?
Wherever you see n. 19, remember, the 19th term just means n is 19. We went through that earlier. Remember the whole a to the n thing versus what is n versus a to the n?
AN would be 19.
Oh, so this.
What's the R? Got it, Mr. Gill.
No. I can't.
I think this is.
But we can't, there's no pattern defined, like there's no number to define the pattern out, but.
Okay, so we have to go back.
And then just do the math on that.
6.
Will they do it?
No, no, right.
Let me see.
Yes, now do the math on the next one. Never leave it like it's that.
18. Oh, yeah, we gotta do the math on this one, so you just turn all that into.
So what do you need to do to finish that? Because you gotta do it for the 19th. Right now, you just told me that'll work for any term. I want to specifically know what that formula would be for the 19th term. You just need to change one thing.
Let's not have the rest.
You gotta help.
Oh, number 9. You need to write down this formula. I mean, you should have it written somewhere, but go ahead and write it on that paper. So
You what?
this is a different kind of formula right here that we didn't do a lot with. So what I want you to do is take that kind of formula. Actually, I guess this whole thing is really. I want you to take that formula and move it into this type of formula. So you should notice some of the stuff is the same. And then I want you to do it for specifically for the 19th term.
I got it, Mr. Gill.
Yeah, I feel so special.
Good.
I got it. I got it.
All right, finish.
Good. So we can talk real quick after class.
This is so fun.
That's all I don't know if you got my message back, but.
This is a very special zone. This is only meant for one person.
We can talk.
Hit me with your best.
So.
There's nothing bad.
This is. Oh, wait, there's stop. Try to change it over to that other format. The one that's above. For the 19th term. What else you're not doing?
Stop saying I'm late.
I want you to show me what you did. Everything you wrote down that I wrote down. So I don't accept, I'm confused, and you don't have one single thing written down.
She was sleepy.
I like to play.
Yeah, you can say, I'm sleepy or whatever.
She was like, hey, y'all can sleep. You don't have to go to the I like them. You.
No, we're sorry.
He's like, go.
It's supposed to be up.
Go to the flow and you.
Oh, well, it would be A, so the N is when you replace the A would still be there. Because we don't know what that term is. That's what it's called. Now, spell it back. What lead? What is?
You know.
Yeah.
The same thing as last time.
Generic formula, all like that. That was A is, A1, R is.
No, yeah.
No. Is it the same thing as last time where you pay for it in person?
No, you gotta buy it offline, like
So check you guys.
I'll go.
Boy.
Alright, so you try.
Oh, y'all need help.
Hey, ain't your thing
So A sub 1. We want to find A sub 1 in that problem number 9.
Look at Jazz.
What is
Jazz,
it,
Jazz,
sub
thinks she's gonna leave, but I give it a piece of that.
Yeah, it literally tells you right here. A sub 1 is 2. It tells you right there. So, 2. Well, the 6 is the pattern number. So the 6 replaces the
What they
R. You see where the R is, like in parentheses, the R? That's what the 6 is.
That's why I flip it around.
Well, if this is a 19.
On a piece of gum.
So, it's not.
On a piece of gum. No, you didn't.
Can you come after school tomorrow and go to
You got it too.
You can come during lunch, I can at least get you a decent day on the next. That's up to you. I can't force you to be here, but if you want to pass this quarter, you need a good grade on this exit, because it's worth a lot of points. But again, I'm not forcing you. So if this, you see how this is an n, right? That's an n. A variable in an equation is always the same number. So if you put a 19 here for that n, that has to be a 19. That's true for any equation. Like, that's why I'm spending the time to talk to you about that specifically, even though it seems like a little tiny piece. Any equation you have. Now, if you move on to another problem and x is in the next problem or n is in the next problem, then obviously that's different. But if you're in the same equation, same problem, whatever you replace that with, better replace that with that same number. That's why this is still in both places. It's got to match up. Now, you're going to then do math, so the final answer would be, I replace that with 19 like you did. This A1 is right there. It tells you what A1 is. So 2, and I think you got that.
Oh my God, they're taking us.
So 6 is the other number. Well, just a second. So again, I replace that in with 19. Don't anybody walk out that door. But I still need this subtract 1 part. So my final answer, the numbers don't match up in that. But that's okay, because the only thing that needs to match up is the n value. Then I subtract 1 from that, and that's why they don't match up in the final answer. But they did initially. So anytime you have a variable in an equation, any equation, x, y, w, z, if you replace that variable with something, you better replace it everywhere with that same thing. Please do, because that would probably allow you to get a passing grade.
I got his bathroom real bad.
Yeah, I'll be here. I'll be here for 45 minutes. Well, actually, more than that. Oh, and that's it. We're done.